That is Mount St. Helens. On May 18th in 1980, it exploded in a volcanic display never before witnessed in modern times.
Up on the west side, the whole west side, northwest side is sliding down.
Something is happening beneath Mount St. Helens. The ground trembles, the air thickens with volcanic gas, and scientists are on high alert. Could this be the prelude to another catastrophic eruption? And even more terrifying, could it be linked to the Yellowstone supervolcano? Deep in the Pacific Northwest, Mount St. Helens is stirring once again. The iconic volcano, infamous for its devastating 1980 eruption, is showing alarming signs of unrest. Rapid earthquake swarms, significant surface deformation, and a surge in volcanic gas emissions have scientists scrambling to decode the warning signs. Monitoring stations reveal the mountain's northern flank is bulging, a pattern eerily similar to what was observed before its last major eruption. Sulfur dioxide levels have tripled, indicating magma movement beneath the surface. Even wildlife is reacting. Elk are fleeing, birds have disappeared. But as emergency officials prepare for the worst, a bigger question looms. Is this just the beginning? Could the awakening of Mount St. Helens be a harbinger of something far more catastrophic? The U.S. Geological Survey (USGS) and the Cascades Volcano Observatory have transformed into 24/7 command centers. Scientists analyze every tremor, every plume of gas, every shift in the landscape. Washington's Emergency Operations Center has activated volcanic crisis protocols. Advanced monitoring technology, far beyond what existed in 1980, is feeding real-time data to experts across the globe. Evacuation routes are being mapped, emergency shelters prepared, and schools in at-risk zones are conducting volcanic drills. But what if Mount St. Helens is just the beginning? Two geological titans dominate North America, Mount St. Helens and Mount Rainier. Helens and the Yellowstone supervolcano. Though separated by over 500 miles and formed by different geological processes, new seismic imaging suggests hidden connections beneath the Earth's crust. Historical data supports this possibility. The eruption of Mount Pinatubo in 1991 triggered unusual seismic activity in distant regions. Could Mount St. Helens unrest be a trigger for Yellowstone? International research teams are now investigating the cascade effect theory, the idea that one volcanic event could set off a chain reaction across an interconnected system of magma chambers and fault lines. The USGS, Yellowstone Volcano Observatory, and international experts are meticulously analyzing seismic data, gas emissions, and crustal deformations. Some findings challenge long-held beliefs about volcanic isolation. The discovery of deep, previously unmapped crustal fractures suggests that Mount St. Helens activity may be part of a larger geological shift with far-reaching consequences. Yet, despite the growing concern, scientific reality offers some reassurance. While Mount St. Helens is active, experts confirm that its behavior, while alarming, remains within expected patterns. And while Yellowstone's magma chamber is vast, only 5 to 15% is molten, far below the threshold required for an eruption. In fact, the statistical probability of a Yellowstone super eruption is just 0.000014% per year. But what if Yellowstone did erupt? The consequences would be unimaginable. The immediate blast zone would turn vast portions of Wyoming, Montana, and Idaho into wastelands. Pyroclastic flows would incinerate everything in their path. Volcanic ash would darken skies across the continent, disrupting agriculture and causing global cooling. Economic losses could exceed $2 trillion, while emergency services would struggle to handle mass evacuations. It's a doomsday scenario, but one that scientists say is highly unlikely in our lifetime. Thanks to cutting-edge monitoring, modern technology now offers early warnings that were unimaginable during the catastrophic eruption of Mount St. Helens in 1980. Advances in seismic instrumentation, satellite imaging, and artificial intelligence have revolutionized how scientists study volcanic activity. The Pacific Northwest Seismic Network continuously tracks even the slightest tremors, providing real-time data on underground movements that could signal an impending eruption. Additionally, real-time gas analysis enables researchers to monitor volcanic emissions, helping to assess magma movement and potential explosive activity. These advancements are complemented by international cooperation among volcano observatories, ensuring rapid communication and coordinated responses to potential threats. Unlikely but not impossible, Science and technology have given us the power to understand, prepare, and react. The key to staying safe is staying informed. If you found this video informative, be sure to like, share, and subscribe to our channel for more deep dives into Earth's most fascinating mysteries. Stay curious, stay safe, and we'll see you next time. Beneath the tranquil beauty of the Pacific Northwest lies a ticking geological time bomb, Mount St. Helens. But now, an even more chilling discovery threatens to rewrite the story of this volatile region. The Pacific Northwest is a land of breathtaking mountains, ancient forests, and a rugged coastline that draws millions each year. Yet beneath its serene exterior lies one of the most active geological regions on Earth. Mount St. Helens, infamous for its catastrophic 1980 eruption, has long captured the attention of scientists and adventurers alike. But recent findings by the U.S. Geological Survey, USGS, have unveiled a terrifying secret: a mysterious leak on the ocean floor near the volcano. What does this leak mean for the future of the Pacific Northwest? And could it trigger a chain reaction of catastrophic events? Mount St. Helens has always been a geological enigma. Nestled along the Cascadia subduction zone, where tectonic plates collide, it's part of a volatile system prone to earthquakes and volcanic activity. In recent years, advanced monitoring tools have revealed seismic rumblings and signs of awakening beneath the mountain. But it's the nearby ocean floor that has shocked the scientific community. During a routine geological survey, scientists detected a strange anomaly: warm fluid seeping from the seabed at an alarming rate. Initially thought to be a typical hydrothermal vent, further investigation revealed something far more sinister. This leak was no ordinary outflow. It was releasing methane, carbon dioxide, and chemical compounds directly tied to magma reservoirs deep beneath Mount St. Helens. The discovery set off alarm bells. These types of leaks often act as pressure valves, signaling instability within the Earth's crust. If the magma chambers feeding Mount St. Helens are under extreme pressure, the consequences could be catastrophic, potentially leading to seismic events or even a volcanic eruption. The leak's location adds another layer of danger. It sits disturbingly close to the Cascadia subduction zone, a region capable of unleashing megathrust earthquakes with magnitudes of 9.0 or higher. Such an earthquake could trigger massive tsunamis, devastate coastal cities, and disrupt life across the Pacific Northwest. To complicate matters, the fluid escaping from the leak is laced with methane, a greenhouse gas over 80 times more potent than carbon dioxide in trapping heat. While the current emissions are small, the risk of larger methane releases looms large. Beneath the ocean floor lie vast deposits of methane hydrates, ice-like structures that trap methane gas. Even minor temperature changes could destabilize these deposits, unleashing a catastrophic feedback loop of warming and gas release. Adding to the mystery, seismic tremors, known as harmonic tremors, have been detected near the leak. These tremors, often linked to magma movement, suggest that the Earth's crust in this area is far more dynamic than previously thought. Some experts speculate that the leak could be part of a deeper, more complex geological system, potentially tied to ancient, dormant structures beneath the Pacific Northwest. The worst-case scenario surrounding an underwater volcanic eruption near the Cascadia fault leak is nothing short of catastrophic. Imagine the sheer power unleashed if volcanic activity were to occur in this already vulnerable region. Such an eruption would instantly displace massive volumes of water, unleashing tsunamis that could race across the Pacific Ocean at speeds up to 500 miles per hour. These towering waves, capable of reaching coastal cities like Seattle, Portland, and even further, would arrive in mere hours, leaving minimal time for evacuation and disaster preparedness. The impact on these urban centers would be devastating, with coastal infrastructures, ports, and residential areas swept away in the blink of an eye. The primary wave of destruction would be immediate and highly visible. Entire neighborhoods inundated, buildings reduced to rubble, and thousands of lives at risk. The force of a tsunami isn't just in its height, it's in its ability to flood miles inland, destroying everything in its path. Seattle and Portland, being major population and economic hubs, would face catastrophic losses. Skyscrapers could crumble under the sheer pressure of water and debris, while key infrastructure such as highways, bridges, and power grids would be rendered useless. The ports, which serve as vital arteries for trade and commerce, would be paralyzed, creating a ripple effect on the economy that could last for years. But the disaster wouldn't stop there. A volcanic eruption near the fault would also disrupt marine ecosystems on an unimaginable scale. The sudden displacement of water would cause shockwaves that could devastate delicate habitats. Coral reefs, already vulnerable due to climate change, would face further destruction. Deep-sea creatures adapted to stable conditions would be subjected to violent changes in temperature and pressure, likely leading to mass die-offs. Entire fisheries could collapse, depriving coastal communities of their livelihoods and disrupting global seafood supplies. The environmental consequences would extend beyond the ocean. Widespread flooding triggered by tsunamis would contaminate freshwater supplies with saltwater, sewage, and industrial chemicals, making clean drinking water scarce. Agricultural lands near the coast would be rendered unusable, compounding food shortages in affected areas. The inundation of urban areas would lead to the release of toxic substances from factories, oil refineries, and hazardous waste sites, causing long-term environmental damage that could take decades to mitigate. From an economic standpoint, the damages would be astronomical. Early estimates for similar scenarios suggest losses could easily climb into the tens of billions, if not more. Insurance claims would skyrocket, and rebuilding efforts would place a massive strain on local and federal governments. The economic toll would not only impact the affected regions, but also ripple through national and global markets, given the strategic importance of cities like Seattle and Portland in trade and technology. Beyond the immediate physical and economic devastation, the psychological impact on survivors and communities would be profound. Entire populations would face displacement, leading to a refugee crisis in regions unprepared to handle such an influx. The loss of loved ones, homes, and livelihoods would leave lasting scars, with mental health issues like PTSD, anxiety, and depression becoming widespread. Efforts to recover from such an event would be monumental, requiring international aid, collaboration, and innovative strategies to rebuild. Yet even with the best recovery plans, the scars left by such a disaster would be indelible. Coastal cities would be forever changed, both physically and culturally, as they grapple with the consequences of living on the edge of one of the world's most volatile geological zones. As scientists race to uncover the truth about this mysterious ocean floor leak, one thing is certain: the Pacific Northwest is sitting on a powder keg. This discovery is a stark reminder of our planet's raw power and unpredictability. While we cannot control the forces of nature, we can prepare and adapt. Will this leak serve as a wake-up call, driving humanity to action, or will it be a harbinger of disasters yet to come? Only time will tell. Stay tuned as we continue to explore the mysteries of Earth's volatile systems, because understanding them might just be the key to our survival. If you're fascinated by the mysteries of our planet and the forces shaping its future, don't forget to like, subscribe, and hit the bell icon. Join us as we dive deeper into Earth's most captivating and terrifying secrets. See you in the next video.